Okay, in previous class we discussed about work. Work done by constant force and work done by variable force. Work done by constant force, the equation was F dot S or Fs cos theta. Work done by variable force, W equals to x1 to x2 F dx. And there was a homework. Suppose F equals to 0.5x plus 10. What will be the work done for x1 equals to 2 meter and x2 equals to 4 or 5 meter, etc. Okay. Homework কেউ করছো? Okay, আসো। Work done, W equals to integration of F dx x1 x2. So the value of F is 0.5x plus 10 dx. Integration x1 to x2. So 0.5 integration x dx, it is 2 to 5 plus 10 integration of dx 2 to 5. So it will be 0.5 into x square by 2, 2 to 5 plus 10 x 2 to 5. Now, W equals to 0.5 by 2, 5 square minus 2 square plus 10, 5 minus 2. 0.5 by 2 into 25 minus 4, 21 plus 10 into 3, that means 30. So total work done will be 21 into 0.5 bhag 2 jog 30 plus 30, that means 35.25. 35.25. So work done W equals to 35.25 joule. Understand? This is the work done in this case. Okay, now we discuss about conservative force and non-conservative force. These topics in your textbooks in the last page. I discussed about it in this time because it is important for the conservation of energy and non-conservation of energy. So now we discuss about the conservative force and non-conservative force. Come on. Conservative force, conservative.
স্যার আরেকটা ম্যাথ ছিল তো স্যার।
ওটা পাওনি?
না স্যার, ওই যে স্যার 2 kg mass goes down 4 meters, gravitational force, tension force.
For a spring.
জি স্যার, ওই যে work done by gravitational force on each masses and tension force on each mass when 2 kg mass goes down to 4 meters.
Okay. Suppose this is the pulley. This net had the mass. What is the mass in this case? 2 kilogram.
2 kg.
Had 1 kilogram.
1 kg. Yes.
When mass down 4 meter.
Yes sir, 2 kg mass down 4 meter.
Okay. Come on. You have to remember for this type of math, weight always acts in this direction and tension acts in this direction. Okay. And for this, weight in this direction and tension in this direction. Suppose this is 1 and this is 2. W1 and W2. And the mass is M1 and the mass is M2. Okay. Now, the tension in both cases are same because there is no change of string. The string are easily moved on the pulley. Over the pulley, then we can say the tension in both cases, this string and this string are the same. So the tension, if the string are same, then the tension will be equal. You have to remember this. So the question was, find work done by gravitational force on each mass and tension force on each mass. Find 2 kg mass down, go down 4 meter. Okay, come on. Work done by gravitational force. Gravitational force, that is that this is it. Suppose it reaches the point here, 2 kg. Okay, and it also go upward direction 4 kg. 1 kg, 4 meter. It's also 4 meter. Okay. Suppose it goes down forward and it is going out upward. It's downward, it's upward. So the distance, traveling distance by 2 kg and this traveling distance by 1 kg will be same. And this distance go downward and this distance upward. Okay, come on. Work done by gravitational force. Gravitational force for 1 kg. Work done by gravitational force for 1 kilogram. Okay. Here the gravitational force acts downward and the displacement is upward. So work done by gravitational force for this, for 1 mass Fg1 as cos theta. Okay. Fg1 means mg, m1g, m1g as cos theta. Come on. M1 means 1, G means 9.8, S means 4, cos theta means 180 degree. Because the direction of force and the displacement are opposite to each other, so then the angle between the force and displacement is 180 degree. So it will be cos 180, that means minus 1 into 9.8 into 4. So the result will be minus 39.2. So work done by gravitational force on 1 kg will be minus 39.2 joule. Understand?
Yes, sir.
Okay. In this way, we can calculate the gravitation work done by gravitational force on 2 kg. Okay. Work done by gravitational force on 2 kilogram equals to Fg2s cos theta. Same equation. Mahidul Islam Ifaz. Oh, Ifaz, na? Okay. Here Fg2 means M2G S cos theta. Cos theta, gravitational force in this direction and displacement also same direction. So the angle between the force and displacement is 0. So we can write cos 0. Understand? Yes or no? Okay. So 2 into 9.8 into 4 into 1. 9.8 into 8, that means 78.4. So Wg for 2 kilogram equals to 78.4 joule. This is the work done by gravitational force on 1 kg. This is the work done by gravitational force on 2 kg. Here you can see in one phenomena, one step work done is negative, another step the work done is positive. First portion is complete. Second portion, work done by tension force, tension on each mass. But we do not know the value of tension. What is the tension? And what is the value of tension? Now, we discuss about the tension. Okay, come on. Okay. The 2 kg must go downward and 1 kg must go upward. For this case, T is greater than W1. For this reason, 1 kg must go upward. So net force on this object, T minus W1 equals to M1A, have the acceleration in this direction. Understand? F equals to MA. F equals to MA, here F is the effective mass. In this mass, the effective force is T minus W1. Understand?
Yes, sir.
Okay. T, we do not know the value of T. Suppose that's one for 1 kilogram mass. Okay. For second body, the body goes downward. So effective force acts downward. So W2 is greater than T. In this case, the acceleration in this direction. So we can write W2 minus T equals to M2A. Understand?
Yes.
Okay. Now, আমরা add kori. So TT cut. So W2 minus W1 equals to M1 plus M2 into A. W2 means M2G minus M1G equals to M1 plus M2 into A. So here A will be M2 minus M1 might of M2. So M2 equals to 2 minus 1 into 9.8, 2 plus 1. Asaf Sinan, shut down the mic. 9.8 by 3, so it will be 3.27. 3.27 meter per second square. This is the acceleration. Putting the value of A, equation number 1, this is the equation number 1 and this is the equation number 2, then we can calculate the tension. Okay, come on. From this equation, we can write T equals to M1A plus W1. M1A plus M1G. So M1A plus G. Now, come on. So we know M1 equals to 1, A equals to 3.27, and this is 9.8. So it will be 3.27 plus 9.8. So it will be 13.07. 13.07. Tension is a one kind of force. So here T equals to 13.07 Newton. Okay. Now we know the value of tension. Now work done by tension force. Okay, come on. Work done by tension force for 1 kg. Come on. This is T equals to 13.07 Newton. You have to remember this. Okay, come on. For this, we know the object is go 4 meter in upward direction. This is 4 meter, and this is go downward direction. This is also 4 meter. Okay. 4. So work done by tension force for on 1 kg equals to tension displacement cos theta. Here the tension is upward direction. We know tension force is 13.07 and 4 cos 0. In this case, cos 0. So we can write 13.07 into 4 into 1. 13.4, 52.28. So work done by tension force on 1 kg will be 52.28 joule. Understand? Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes.
In the same way, work done by tension force on 2 kilogram. Work done by tension force on 2 kilogram. It will be tension displacement cos theta. At tension 13.07, displacement for cos theta. Here the tension is upward direction and displacement downward direction. So the angle between the tension and displacement will be 180 degree. So cos 180 degree. So it will be 13.07 into 4, 52.8 minus 52.28 minus 52.28. Okay. Minus 52.28 joule. So W2 on 2 kilogram, it will be minus 52.28 joule. Understand?
Yes, sir.
Okay. Now we discuss about conservative and non-conservative force. Come on. Conservative and non-conservative. At first we discuss about conservative force. Conservative force. Conservative force, in your textbook, it is written that when the work done is 0, then the force is called conservative force. You have to remember this conservative force is a one kind of force. This is a conditional force. Conditional force. What is the condition for conservative force? Come on. Conservative force, the work done, suppose the work done by such force number 1 does not depend upon path, does not depend upon path. Second number condition, depends only and only on initial and final position. Okay. Position. Conservative force is such force, the work done does not depend upon path, and if the work done depends only and only on initial and final point. Come on. Suppose A and B are 2 points. You can go through this line. This is the path number 1. You can go by this path. This is the path number 2. You can go in this way. So this is the equation path number 3. According to the conservative force, if you want to go from A to B, the force is applied in this direction. Applying force, or you can go this direction or this direction. So this the angle making displacement force is theta. Then you can go in among this path. So work done according to the conservative force, W1 equals to W2 equals to W free. Because for path number 1, initial point A, final point B. For path number 2, initial point A, final point B. For path number 3, initial point A and final point B. In 3 cases, the initial and final point are same. For the condition, we know the work done depends only and only initial and final point. For this reason, we can say work done in 3 paths will be equal. That is the W1 equals to W2. Okay. Conservative force, such as this is the gravitational force. This is a conservative force. Gravitational force. Gravitational force. Okay. And 2 number hello spring force. Number 3, electrostatic force. Electrostatic force. They are the conservative force. Why they are called conservative force? Come on. At first we discuss about the gravitational force. Then we can discuss about a short technique why you can calculate the conservative force. Okay. Gravitational force. Suppose that is the path. Here A, B, and C. Come on. There is an object here. The mass of the object is m. And it travels along this direction. The length of this path is L. This is the path number 1. And this is the initial position and this is the final position. Okay. Another path is here, A to B, B to C. This is the path number 2. Now we calculate here work done for path 1 and path 2 according to the gravitational force will be equal or not. Is equal, then we can say that is the gravitational force is a conservative force. Come on. For path number 1, work done by gravitational force. Okay. For this mass, this angle is theta. Suppose this angle is theta. For this mass, the gravitational force acts in this direction. Such as this is the Fg, gravitational force. Fg equals to mg. So work done by this force equals to Fg L cos theta. Suppose Fg L cos theta, or we can write as at first we can write Fs cos theta or Fs cos theta. Jubair Abir, please shut down the mic. Fs cos theta. Here F equals to mg, S equals to L cos theta. Now, what is the theta here? Theta, force in this direction, displacement in this direction. The angle between them is 90 degree. So theta will be 90 degree plus theta. So theta 90 degree plus theta. Such as it is alpha. So alpha equals to 90 degree plus theta. Come on. So MGL, this is the minus sine theta. So WG for one path will be minus MGL sine theta. Okay. For path number 1, so work done by gravitational force will be, gravitational force is minus MGL sine theta. So we can write work done by gravitational force path 1 minus MGL sine theta. Okay, come on. For second path, work done by second path. Okay, work done by gravitational force on second path, it will be work done by second gravitational second path by gravitational force on second path. It is A to B and B to C. At first it goes A to B, then it goes B to C. Okay, come on. Work done on AB path plus work done on BC path. Because what is a scalar quantity? Scalar quantity. If you determine the work done for AB and BC, then you can get the work done the total path. Okay, come on. Work done by gravitational force on path AB, it will be 0. Why? Because the angle between the gravitational force and displacement is 90 degrees. We know when the force and displacement are perpendicular to each other, then work done is 0. So for this case, the work done is 0. Okay, come on. For this path, B to C, her gravitational force is in this direction, and displacement this BC. We do not know the value of BC. Suppose this is the H, this is the mg. So we can write FH cos theta. No, it is alpha. Okay. Now F equals to mg. What is the value of H according to the L? Now come on. H, this is the, for this angle, H is the perpendicular. H is the perpendicular distance. H normal, L hypotenuse. So H by L equals to sine theta. So we can write H equals to L sine theta. So we can put L sine theta instead of H, so it will be L sine theta. And here the angle between the force and displacement is 180 degree, cos 180 degree. So minus mgl sine theta. So according to this discussion, we can see the work done by gravitational force on path number 1 and path number 2 are same. W1 equals to W2. So we can say gravitational force is a conservative force. Understand? Work done by gravitational force is a conservative force. Okay. Write a note. Work done by conservative force. Work done by conservative force. Conservative force work done by conservative force in a closed path is always 0, is always 0. Okay, is always 0. Suppose A to B, B to C, C to A, D to A. Here, suppose A to B, B to C, C to D, D to E, and E to A. In this case, total work done is 0. If the force is conservative force, then we can say work done in a closed path will be 0. Okay, come on. There is another condition, that is the non-conservative force. Come on. Non-conservative force, the work for non-conservative force. This is the conservative. We can write non-conservative. N-O-N-Z-S-O-N-S-E-R. Non-conservative force. Okay. For this, work done depends upon path. Work done depends upon path. Act. Second number condition, in closed path, work done, W is not equals to 0. W is not equals to 0. Such as common. frictional force. Suppose an object goes down from A to B. The mass of the object, suppose this is the mass of the object M, and displacement is S. This is the mass M. A frictional force acts in this direction. Come on, frictional force in this direction. So, work done by frictional force, in this case, W equals to minus Fs. In shortly, minus Fs. Why it is minus? Because the displacement and force are opposite to each other. Okay. Then after it reaches this point, it returns this direction. And for this, the frictional force acts in this direction for B case. When it comes to, we can write work done A to B equals to minus Fs. For work done B to A, it also Fs. Minus Fs. So total work done equals to minus 2Fs. So in this case, work done is not 0. You have to remember, closed path means the circle. If in a linear direction, if the point reach the initial position, the work done is not 0 by the frictional force. Okay, another example, suppose there is a table, and this is the table, and an A object here, another object is B here. It can go for A to B in this direction. This is the path number 1. It can go this direction to this direction, this, and this. This is the path number 2. And in this case, you have to remember work done is W1 is not equals to W2. Why? When it goes this direction, the frictional force acts this direction. So work done, and when it goes from this direction, the frictional force acts this direction. When this path, frictional direction force this path. When it reaches here, the frictional force acts this direction. So work done is not 0 here. So W1 is not equals to W2. You have to remember this. So this force is called the non-conservative force. Okay, there is a condition for conservative and non-conservative force. Come on, quick. Suppose the force F equals to, we can write I Fx plus J Fy. Okay, come on. For check, for conservative force, delta Fx by delta Y equals to delta Fy by delta Fx. Ek number condition. Number 2 condition, Fx by Fz will be Fz by Fx. Number 3 condition, delta Fy delta X equals to delta, third number condition, delta Fy by delta Z equals to delta Fz by delta Y. Okay, this is the condition. It's all are not equal. If this portion is equal, this portion is equal, this portion is equal, then we can say that force is called the conservative force. Come on, we can calculate a math. Suppose. Okay, this is the condition. Questions. F equals to 3yi and 4xj. 4x now, 3x, suppose 3xj. The force is conservative or non-conservative? Check it. Okay, come on. At first, we can say this is the Fx and this is the Fy. Okay, come on. Now, delta Fx by delta Y equals to delta Fy by delta X. Okay, Fx means delta Y fx means 3y equals to delta x. So yes, this is the 3x. So it will be 3 into 3. That number is satisfied. Number 2, checked. There is no function of jet. You cannot calculate. So this is a conservative force. This is a conservative force. Okay. Now there is a homework. Come on. F equals to 3yi plus 4xj. 3iy and plus 4xj. It is conservative or non-conservative? Explain it. So thank you, student. You must try at home to do this math. It is your duty to continue your tasks regularly. The number of